Hi, my name is Alexander. Welcome back to my channel. In a previous video, we have created routing for the Angular non-standalone projects, which is applicable to the applications created with the Angular versions up to 13. In this video, we will implement routing for the Angular standalone projects. Starting from Angular version 17, new projects will be standalone by default. Therefore, we don't need any additional options when creating a new project. Let's create Angular standalone project. Go to Projects directory. Check Angular version. Angular version is 18. Open Visual Studio Code. Open auto-generated app component. We see that this is a standalone component with a property standalone true. Let's create two new components. Open terminal, first component, second component. Open components view and change the message. Now, when the first component is loaded in a browser, we will see the message component first works. When the second component is loaded in a browser, we will see the message component second works. Create CSS classes. Import components into application component. Remove the code from app component HTML. Create a table in app component.html and add components selectors in the table's cells. We have to compile and start application. This command with the flag O will build and automatically open our application in the browser after compilation. Both components are loaded when application starts. Let's use routing to load components. To get the directives needed for this, we can directly import the router module into our standalone component. However, a better alternative is to just import the directives we need. Router outlet, router link, and if needed, router link with href. Href is the basic attribute provided by HTML to navigate through the pages, which reloads the page on click. Router link is the attribute provided by Angular to navigate to different components without reloading the page. Major difference between both is that href kills the state of the current page, where router link doesn't lose the state of the page. For example, if input text box is present on the page, the router link will retain its value after navigation. The router link can be considered as the custom attribute of href in Angular by overriding some of the features like page reloading. In the current project, we will not use router link with href. We have to define the route object that maps a URL path to a component, and the router outlet directive that is used to place routed view in a template. We didn't use Angular router to load components, therefore app routes doesn't contain any routes for the components. Routes array is empty. Route tells the router which view to display when a user clicks a link to URL. Let's comment out the component selectors in app component HTML. Instead, we will create routes in app routes for loading our components. Import components and create a routes. The simplest route consists of the property path. It is a string that specifies the URL path for the route. And property component, it is a string that specifies what component your application should display for that path. We need to register the routes at the time of application startup. The application startup code is in the main.ts file. Bootstrap application method is responsible for rendering the route component. It expects two arguments. The component to render when the application starts, application config object, which provides the set of configurations for the Bootstrap application method. The application config contains only one member, the providers array. In the providers array, we register every service that needs to be made available to the root component and all of its children. Hence, we need to add the Angular router related services in the provider's array. The provide router is a helper method that registers the services related to Angular router and configures the routing. This is where we register the routes we created. In the app component.html, add links to the components. Add router outlet. The router outlet is the directive that's available from the router library, where the router inserts the component that gets matched based on the current browser's URL. You can add multiple outlets in your Angular application, which enables you to implement advanced routing scenarios. We will do it later in this video. Router outlet, it is a placeholder for the components that we will load by clicking the router link. We put the router outlet in the next row of our table. Compile and start application. Click first component. The first component is loaded in the router outlet placeholder. Click second component. The second component is loaded in the router outlet placeholder, replacing the first component. If we need that both components can be loaded on the page, we have to create auxiliary route. To create an auxiliary route, we will need a named router outlet, where the component associated with the auxiliary route will be displayed. Let's add additional router outlet with the name second. Add the name of this outlet to outlet property of the router for the second component. The syntax of the router link for the second component should be corrected as well. Compile and restart application. Click first component. Click second component. Now by clicking the router links, we can load both components. Programmatic router navigation. Another way of doing router navigation is to use the router programmatic API to do so. For that, we just have to inject the router into our component and make use of either the navigate or navigate by URL navigation methods. Let's do it for the first component. Import router from Angular router package. Inject the router into the app component and create the method first component to navigate to the first component. Comment router link for the first component and add the button. The first component will be loaded by button click. Compile and start application. First component is loaded, second component is loaded. Route guards. A route guard is a feature of the Angular router that allows developers to run some logic when a route is requested, and based on this logic, it allows or denies the user access to the route. It's commonly used to check if a user is logged in and has the authorization before he can access a page. In Angular 14.2, functional route guards were introduced as a new way to protect parts of Angular applications. Previously, the only way to write route guards was by using class-based guards. The class-based guards worked fine, but required a lot of extra setup to be used. We used in a previous video. In many ways, writing functional route guards is way easier than it was previously. You don't have to remember to implement an interface or anything like that. All it requires is a function which returns a function. The inner function is of a given type, like can match fn or can activate fn, for example. However, you don't necessarily need to know what type of function you are returning. Create guard function TS file. The can activate fn has two optional parameters, activate route snapshot and router state snapshot. Because I am not using those parameters, they are not included. Usually, route guard is used to block access for non-authenticated user. But in a current implementation, for the simplicity, we block access to the route based on the day of the week. The function prohibits to load component every Sunday. The getDay method of the date instance returns the day of the week for this date according to local time, where 0 represents Sunday. Guard function returns false for Sunday and true for all other days of week. Add can activate attribute to the road for the first component. The value is guard function. Today's day is not Sunday. Try to load first component. We can load first component. Let's change the rules so that the first component can be loaded only on Sunday. Compile and start application. Try to load first component. The guard method can activate works. We cannot load first component today. Nesting roads. Angular router allows you to have roads nested inside already defined roads. With child roads, you can have a component-like structure defined for the roads in your application. It is critical as there are views that the user should not be able to access unless they are in a particular view. This way the structure becomes tree-like, just like the structure of components. We will create the child roads and display the components we link to them. Create child components. Add these components as a child components to the second component. Add roads for these child components in app roads.ts. A child road is like any other road, in that it needs both a path and a component. The one difference is that you place child roads in the children array within the parent road, which is road for the second component. In the second component.html, we have to add router links to a child components. Let's create a table for this. We have to indicate only path child1 for the component second child1 component and path child2 for the component second child2 component. Road matching algorithm will append each of these paths to the path of the parent component to get the whole URL path for the child components. Add router outlet directive. It is a place where child components will be loaded. Compile and test application. First component loaded. Second component loaded. Second component contains the links to a child components. By clicking the links, we can load child components. Second child 1, second child 2. Road matching strategies. The Angular router provides different road matching strategies, prefix and full. The default strategy is prefix. Prefix match full means that the whole URL path needs to match. Path match prefix means the first road where the path matches the start of the URL is chosen. For example, for our child components, it is second component. But then the road matching algorithm is continuing searching for matching child roads where the rest of URL matches. It is child 1 or child 2. Lazy loading. Lazy loading in Angular refers to a technique where you only load the modules or components that are necessary for rendering the current view, rather than loading the entire application upfront. This helps in reducing the initial loading time of the application, as only the essential code is fetched initially, and additional parts of the application are loaded on demand as the user navigates through the application. To implement lazy loading, we have to use load children or load component property of the road interface. In the past, a lazy road pointed to an ng module with child roads. As there are no ng modules anymore, load children can now directly point to a lazy routing configuration. This makes our code more explicit. For this, we can create separate file containing roads for the lazy load components and load this file using the load children property. When the file with roads is successfully loaded, then we get access to the roads and can load these components. Create separate file first.road.ts with a road for the first component. In app roads, remove the reference to a first component, implement lazy loading for the first.road file, and get roads object containing the path to the first component. Compile and test. The first component is lazy loaded because the file with the roads object containing the path to the first component is lazy loaded. As an alternative, a lazy road can also directly point to a standalone component. Let's implement lazy loading for the first component. In app roads, we will use load component property where we dynamically import the first component. And when the import is successful, we get a reference to a component file and load a component. First component is lazy loaded using the load component property. When we want lazy load a parent component, all its child components are loaded together. Configure lazy loading in routing for the second component. Create second roads file containing the roads for the second component and its child components. In app roads, configure lazy loading for the second component using second.roads file. In app roads, remove references to the second component and its child components. And configure lazy loading for the second component using second.roads file. Compile and test application. First component, second component, and child components. Now the first and the second components are lazy loaded. Let's implement lazy loading for the second child1 component, which is a child component of the second component. Update second roads.ts. Now the second component is lazy loaded, and its first child component, second child1 component, is lazy loaded too. But the second child component, second child2 component, is eagerly loaded. Let's compile application and test. Both components and child components are loaded successfully. One last thing that I have to mention. In a road, the path can take a wildcard string, double asterisk. The router will select this road if the requested URL doesn't match any paths for the defined roads. This can be used for displaying a not found view or redirecting to a specific view if no match is found. One of the key things to know about routing configuration is that the order matters a lot. When the router receives an URL, it will start going through the configuration in order, starting with the first element of the configuration array. If it finds a match to complete URL, it stops and instantiates the corresponding component. So in this case, if we would put the fallback configuration in the beginning of the array, every URL will match to the double asterisk wildcard and this break routing. That is why we should put the fallback route configuration at the last entry of the array. In the video description, you may find a reference to a source code in a GitHub. Thank you for watching. Please subscribe to my channel and have a good day.